Hello there, and welcome. I'm glad you made it here tonight. Maybe you're lying down after a long day, or maybe you're the kind of person who prefers to fall asleep to stories of the cosmos instead of counting sheep. Whatever brought you, you don't need to do anything now but rest. Let your shoulders sink. Let your breath slow. Imagine yourself drifting, weightless, the way starlight drifts across the night. Because tonight we aren't staying close to home. We're leaving the familiar skies of Earth and following a traveler from another star system, a visitor so rare that only 2 have ever been seen before. Its name is 3I Atlas, the third confirmed interstellar object to enter our solar system, a fragment from a world we'll never see, carrying secrets written in ice, dust, and light older than the sun. We'll wander through 100 quiet truths about this cosmic messenger, its discovery, its chemistry, its journey, and the mysteries it still carries. Facts that are strange, wondrous, and sometimes unbelievable. Now, take a deep breath, let your day drift away, and let's travel together into the quiet corners of the universe. On the first night of July in 2025, the Atlas survey cameras in Hawaii were doing what they always do, scanning the crowded sky, clicking image after image in their nightly vigil for dangerous near-Earth asteroids. To the machines, it was just another sweep of stars. But within that scatter of points, deep against the cluttered background of the Milky Way's core, there was one pixel that didn't belong. It was faint, so faint that most human eyes wouldn't have noticed it at all. Yet in the data, the speck glimmered with a subtle difference, not pinned in place like the countless suns behind it. It was in motion. At first, the system flagged it the way it has countless times before, an unremarkable object, perhaps a small asteroid or a dim comet. Nothing unusual in that. The universe is littered with drifting stones and ice. But when astronomers began to compare images, laying one frame over another, measuring the position with meticulous care, the faint point betrayed itself. It was sliding across the sky just a little too quickly. Its arc wasn't quite right, its pace not quite ordinary. Something about it whispered of distance, of velocity, of a path that didn't belong to our sun. The discovery logs note the time in neat precision, the 1st of July 2025. But history rarely announces itself with trumpets. On that night, it arrived only as a ghostly dot, blinking into existence on a computer screen. Still, those who looked closely felt the familiar prickle of recognition. Astronomers live for that moment. The instant when a line of numbers or a subtle streak on a photograph hints at something larger, stranger, something that asks the imagination to stretch. For the Atlas team, that night was one of those moments. Within hours, emails began to circulate. Observatories across the world alerted. The Gemini South Telescope in Chile turned its gaze, its massive mirror cutting through the atmosphere with clarity far beyond the smaller survey scopes. The faint traveler was confirmed. It was not an artifact, not a trick of noise, but a real body out there in the dark. Further checks followed. Other telescopes, other nights, and each one sharpened the picture. Its movement was measured again and again. The math refused to soften. The orbit was hyperbolic. That single fact changed everything. Comets and asteroids bound to the sun move in ellipses, some tight, some stretched, but always closed, always looping back eventually to the star that holds them. This speck did not curve inward to return. Its path was open, flung wide, a trajectory that would carry it in, swing it around, and cast it back out forever. That kind of orbit is not the signature of a solar system child. It is the signature of a stranger. The word spread quickly through the community. Interstellar. The third one ever confirmed. First had been Oumuamua in 2017, the second Borisov in 2019, and now this. Each had carried its own peculiarities, its own hints of the vast processes beyond our reach. And now, In 2025, another messenger had arrived. This one glowed faintly, comet-like, already teasing the presence of a coma, a halo of vapor and dust ignited by sunlight. It was alive in a way Oumuamua never appeared to be, and its behavior was unlike any comet native to our skies. Even before the wider public knew, among astronomers there was a kind of reverent hush. Interstellar objects are more than discoveries. They are encounters. They are reminders that our solar system is not isolated, that the void between stars is not empty, but seeded with fragments from alien worlds, crossing paths for a heartbeat before vanishing again. To catch one in the act is like finding a seashell washed onto shore from a continent you will never visit. You turn it over in your hands, marveling at its ridges, knowing it carries a story from somewhere far beyond the horizon. In the following days, as the data was refined, suspicion hardened into certainty. The faint speck was given a designation, 3I divided by 2025 P1, soon nicknamed Atlas in honor of the survey that first spotted it. Even the name carried weight. Atlas, the one who held up the sky, fitting for an object that seemed to bear the weight of another world's history. The calculations showed its speed, its angle of approach, its inevitable exit. Millions of kilometers would separate it from Earth at closest pass, but that didn't matter. The significance wasn't in proximity, it was in provenance. And so July 1 became a date marked quietly in the annals of science. The night a faint point of light signaled that we were being visited again. The astronomers who stayed up late at their screens, cross-checking coordinates, felt something rare. The tremor of recognition that we were witnessing a phenomenon bigger than ourselves. For the rest of the world, it would take days or weeks for the news to ripple out. But for those first watchers, it was already clear. This wasn't just another comet. This was a messenger from the stars, a brief reminder that the universe is larger and stranger than we can hold in mind, and that sometimes, without warning, it comes to our doorstep unannounced. When scientists first pinned a formal name onto the visitor, it looked dry and clinical, a string of symbols that would mean little to most. 3I divided by 2025 P1. But within that tangle of characters is a story, a classification, a recognition of just how rare this sighting truly is. The 3I is the part that matters most. The I stands for interstellar, a marker used only when an object is proven to come from beyond the reach of the sun. The number 3 marks its place in history, not the first, not the second, but the third confirmed interstellar object ever discovered. 3. Out of the endless billions of stars and planets in our galaxy, in all the centuries of human watching, only 3 have been caught crossing our skies. To carry that designation is to wear a crown of rarity, to be recognized not simply as another comet, but as a messenger from beyond. The second part of the name, 2025 P1, follows the standard cataloging system. The year of discovery, the period of detection, the order within that period. It ties the object into the steady record-keeping of astronomy, the ledger where all comets and asteroids are tracked. But what people remember is not the code, but the chosen name, Atlas. It was named for the survey system that found it, the Asteroid Terrestrial Impact Last Alert System, whose watchful telescopes in Hawaii first caught sight of the faint traveler. There is a certain poetry in that. Atlas, the mythic figure who held the heavens on his shoulders, now lent his name to a fragment of another world drifting through ours. The title feels weighty, almost destined, as if the act of naming transformed a dim speck into a story the whole world could share. To understand why Atlas stands apart, it helps to recall what usually passes through the night. Comets and asteroids are both born within solar systems, siblings of planets and moons, fragments left behind from the turbulent days of formation. Asteroids are mainly rock and metal, silent and solid, tumbling through space like bones of unfinished worlds. Comets are ice-rich, wanderers of the coldest reaches, their frozen shells igniting into glowing comas and streaming tails when they approach the warmth of a star. Both are common, millions of them looping endlessly around the sun in well-mapped orbits. Their paths may be long, their periods stretching thousands of years, but they belong here. Their parent star's gravity holds them close, invisible threads binding them in a cosmic family. An interstellar object breaks those rules. Its orbit is not a loop but an open curve, a hyperbola that carries it in and out, never to return. That difference, subtle in the mathematics, is immense in meaning. It signals an origin far away, a birthplace around another star entirely. Oumuamua was the first, discovered in 2017. It was small, elongated, dark, and strangely silent, showing no coma, no visible activity, only its odd shape and peculiar acceleration to puzzle astronomers. It slipped past quickly, leaving behind questions more than answers. 2 years later came Borisov, unmistakably cometary, with a bright tail and a behavior that felt familiar even though its chemistry whispered of alien origins. Borisov was like a comet we knew, but touched by a different hand. And now, Atlas. It carries traits of both, but also something uniquely its own. Like Borisov, it has shown a coma, proof that volatile ices lie within, yet its proportions of gases are unlike what we see in our local comets. Its signature is rich in carbon dioxide, a composition hinting that it was formed under conditions colder, perhaps harsher, than the nursery of our own Oort cloud. It is neither entirely alien in form nor comfortably familiar, but something in between, a bridge that invites comparison while refusing to be explained away. This balance is what makes it so compelling. It is strange enough to stretch our imaginations, yet close enough to measure and study with care. For astronomers, Atlas is a gift. Oumuamua flashed past too quickly, slipping into the darkness before instruments could fully turn toward it. Borisov was better, active and bright, but still faint, still difficult to track in detail. Atlas was found early enough, in time for observatories around the world to coordinate months of observation. It will be studied by giant mirrors on Earth, by Hubble, and by the eyes of the James Webb Space Telescope, each one peeling back layers of mystery. It is not just a rare encounter but a prepared one, a chance to gather the kind of data that might anchor years of speculation with hard numbers, with spectra, with chemical fingerprints no theory can dismiss. But beyond the science, there is the wonder of it. The designation 3 carries the weight of improbability. To be the third is to be part of a lineage, a pattern beginning to emerge, no longer an isolated oddity, no longer a fluke, but evidence that the galaxy is full of such travelers, slipping between stars, crossing gulfs of darkness until chance delivers one into our watchful sky. Atlas is not just a single comet. It is a reminder that the space between suns is alive with fragments of creation, silent voyagers that may carry whispers of other worlds in their dust. And for a short while, we are allowed to witness one, to name it, to let it pass briefly through the stories of our own species before it vanishes again into the deep. When astronomers describe the orbit of 3I Atlas, they use a word that almost never applies to the familiar comets of our sky: hyperbolic. Most comets trace ellipses around the sun, long-stretched ovals that might take centuries or millennia to complete, but always curve back in on themselves. Even the distant Oort cloud comets, stirred from their icy cradle at the edge of our solar system, are bound to return eventually. But Atlas does not bend inwards into a loop. Its path is not closed. It is open, flung wide, like an arrow shot across the heavens that never slows enough to turn back. That is what a hyperbolic orbit means, a trajectory with no return. The mathematics of this path are precise, but their implications are simple. Gravity is a tether, and for any object born here, the sun's pull is strong enough to keep it. A comet from the Oort cloud may venture so far that it takes 10,000 years to be seen again, but it is still tethered, still attached, by that invisible leash of gravity. For Atlas, the leash is broken. Its velocity is too high, its angle too sharp. Even as the sun pulls on it, trying to bend it into a curve, the object resists. The geometry of its path says everything. It has come from beyond, and it will not stay. At closest approach, Atlas races through space at tens of kilometers every second. To imagine that speed, picture the Earth itself moving through its orbit, 30 kilometers each second, fast enough to circle the planet in a matter of minutes. Atlas outpaces that, cutting through the inner solar system like a stone skipped across a pond. At that speed, there is no slowing, no lingering. The sun can warm its surface, ignite its coma, and stretch a tail of dust and gas behind it, but it cannot claim it. Once Atlas rounds the sun at perihelion, the same momentum that brought it in will carry it out again, back into the darkness between the stars. It is this speed that marks it as foreign. Local comets cannot simply accelerate themselves to such velocities. They can be tugged, perturbed, bent, but always they are kept within the family. Only an outsider arrives already moving so quickly that even the might of the sun cannot hold it. That is why astronomers knew, from the first calculations of its orbit, that Atlas was not one of ours. Its very presence was proof that it had been born elsewhere, in the distant reaches of another system, and ejected long ago into a journey that might have spanned millions of years before it crossed our sky. Because the orbit is hyperbolic, it carries a kind of finality. Atlas will pass close enough to be seen, studied, admired, but then it will leave forever. There is no second chance, no cycle of return as with Halley's Comet or the countless icy wanderers of our own outer reaches. Once it is gone, it will vanish into the depths, fading into invisibility, another unlit traveler among the galaxy's billions. This is part of the bittersweet wonder of interstellar objects. They are gifts that arrive unannounced and leave without farewell. Yet within the shape of its orbit lies a story of its origin. A body does not simply accelerate to such a speed on its own. Something must have thrown it, a gravitational encounter powerful enough to eject it from the cradle of its home system. Perhaps a giant planet, massive like Jupiter, swung it outward during a close pass, catapulting it beyond the gravity of its native star. Perhaps a chain of encounters nudged it step by step until at last it escaped. Whatever the details, the result is the same. Atlas became unbound, cast adrift into interstellar space. For millions of years it wandered unseen, frozen and silent, until by chance its trajectory carried it near our sun. That chance is what makes the moment extraordinary. For every interstellar object we catch, countless others pass unseen, their paths never crossing the gaze of our instruments. The galaxy is seeded with such fragments, relics of long-vanished collisions and planetary migrations, each carrying the fingerprints of alien chemistry and distant histories. Atlas is one of them, a shard of another world's making, carrying with it the memory of a system we will never visit. Its orbit is the signature of that exile, the long equation that tells us it does not belong here and never will. To watch it move is to feel both intimacy and distance. Intimacy, because for a brief time it comes close enough to touch our lives, visible in our skies, traceable by our instruments, whispering its secrets in spectra of light. Distance, because that encounter is fleeting, and we know with certainty that it will not return. The Hyperbola sketches that destiny in the heavens. There is no loop, no repetition, only a passing. In that way, Atlas mirrors many things we experience. Encounters brief and luminous, moments that cannot be held, arrivals that already carry within them the certainty of departure. And so the orbit of Atlas is more than a set of numbers. It is a message about where it came from and where it is going. It tells us that the galaxy is restless, that worlds fling fragments into the void, that those fragments sometimes come wandering into our view. It tells us that our sun is not the center of all paths, but only one star among billions, unable to bind every traveler it meets. It tells us that we are not alone in having comets or collisions, or the restless scattering of worlds. Atlas has come from beyond the sun, and its journey reminds us that the solar system is not an island. It is a shore, and every so often, something washes up on it, carrying news from another sea. As summer tilts toward autumn in the year 2025, astronomers wait with a quiet anticipation. They know that on October 30th, the strange interstellar traveler will reach its perihelion, the point of closest approach to the sun. For Atlas, this is the heart of its fleeting performance. The moment when icy layers that have slumbered in darkness for untold millions of years are suddenly exposed to the furnace of solar light. At that distance, about as close as Earth's own orbit but angled in such a way that it will pass millions of kilometers away from us, it poses no danger. There is no risk of collision, no shadow of doom trailing behind it. Its journey is not toward us, but past us, grazing through our neighborhood in a trajectory that will fling it outward forever. Still, for those watching, this is the closest it will ever be, the brief window when its features can be seen with the greatest clarity. Perihelion is the time when comets awaken. Their frozen crusts, locked in silence for eons, are suddenly kissed by sunlight. Molecules trapped deep within, water, carbon dioxide, carbon monoxide, begin to sublimate, escaping as gas. Dust grains, once bound in the ice, are released and swept outward by the solar wind. What was once a mere nucleus, a black shard no larger than a mountain, transforms into something luminous and alive, surrounded by a glowing coma that can stretch thousands of kilometers across, with a tail drawn thin and bright across the night. To see a comet near perihelion is to see it at its most expressive, as though a mute stone has found its voice. Atlas, in its October passage, will have that moment of brilliance, revealing what it is truly made of before vanishing again into obscurity. From Earth, the comet will never blaze like the great comets of history. It will not dominate the sky as Hale-Bopp once did in the 1,990 seconds, or stretch across the horizon like the legendary comets that startled ancient civilizations. Its path keeps it too far, its nucleus too modest. But for those with telescopes, binoculars, or even dark rural skies, there is promise of a ghostly glow. Astronomers predict it will reach a brightness just on the edge of naked eye visibility, a faint blur against the stars, best appreciated with patient gazing. To the unaided eye, it will appear delicate, perhaps disappointing to those who expect fireworks, but enchanting to those who know what they are seeing, because that faint light will not be just another comet. It will be light from another star's child, a wanderer older than the Earth, showing itself for the briefest time. The safe distance at which it will pass matters less to astronomers than the opportunity it affords. At perihelion, instruments on Earth and in space will gather their richest data. Spectrographs will dissect its coma, teasing apart wavelengths of light to identify the gases escaping. The James Webb Space Telescope will peer into its faint glow, searching for the fingerprints of alien chemistry in the infrared. Ground-based telescopes will map its dust tail, comparing its behavior to that of comets we know. Every detail of its activity near perihelion is precious, because it is activity under heat that reveals a comet's true composition. Like a book held too long shut, Atlas only opens under the warmth of the sun. There is a long tradition of comets captivating humanity, and inevitably, Atlas will be measured against that lineage. Oumuamua, the first interstellar object, never bloomed with a coma at all. It slipped by as a featureless shard, and though it puzzled us with its acceleration, it left no glowing spectacle for the eye. Borisov, the second, was more generous, displaying a tail much like comets of our own solar system, though it was faint and demanded careful instruments to reveal its differences. Atlas falls between these two ancestors, active but subtle, foreign yet familiar. It is not the bright banner of Halley or the great comets that have startled history, but it is unmistakably alive, a comet in the truest sense, and one that comes from far beyond our own system. That is why its faint visibility carries such weight. To know that a person standing on Earth can look up on a clear October night, find a smudge of light barely above the horizon, and realize that they are gazing upon a body that formed around another star is to feel the boundaries of home stretch wider. The experience will not be dazzling in the way of fireworks. It will be quiet, subdued, requiring patience and perhaps guidance. But in that patience lies its gift. For those who know what they are seeing, the faint glow will carry a grandeur that no spectacle can match. Proof of the galaxy's vast connectedness. Proof that matter and motion do not stay confined, but cross the gulfs between stars. As the date draws near, anticipation grows not because Atlas will light up the sky for the masses, but because it will whisper across our instruments and our eyes. October 30 will come and go, the world turning as always, but those who look will have seen a rare visitor at the height of its journey, a comet shining brightest at the very point it prepares to leave us. The comparison to other comets is instructive but secondary, because this one carries a title only two before it have ever borne. It is interstellar. Its perihelion is not just a brightening, but a revelation. It is the one moment when the traveler from another star system fully reveals itself, and then begins the long return to invisibility. In the days after perihelion, it will already begin to fade, its coma thinning, its dust dispersing, the sun's warmth slipping behind it as it races outward. Those who do not look in October may miss it forever. There will be no second visit, no later apparition. That is what makes this approach so urgent, so fragile, so wondrous. Perihelion is the peak of its story in our skies, a single page illuminated before the book snaps shut again, carried away into the dark. In the language of comets, the word coma carries a strange beauty. It is not a sleep, but a halo, a cloud of gas and dust that blossoms around a frozen nucleus when sunlight strikes it. A comet alone, unlit, is just a dark stone or lump of ice, rough and silent. But near a star, the warmth seeps in and awakens it, unlocking volatile ices trapped for billions of years. These gases expand outward, dragging grains of dust with them, forming a luminous shroud that can swell to thousands of kilometers across. To an observer on Earth, that shroud is what makes a comet appear alive, glowing softly against the night as though a hidden lantern had been lit inside. With Atlas, that transformation has already begun. At first it was only a faint star-like point, nearly indistinguishable from the backdrop of the Milky Way. But as it neared the sun, telescopes revealed the subtle swelling of light around it, too broad to be a star, too diffuse to be a simple asteroid. It was a coma, delicate, ghostly, yet undeniably there. To most eyes it would appear as little more than a haze, but to astronomers it was proof that Atlas was a true comet, not just a rock adrift from another system, but an active body releasing its ancient secrets into the solar wind. What makes a coma mesmerizing is not only its glow but its dynamics. Every particle of gas that escapes the nucleus is shaped by forces larger than itself. Sunlight pushes outward, solar wind streams around it. The coma is not a static shell, but a breathing, shifting veil. Within it, dust grains scatter light, sometimes producing subtle hues. Atlas's coma, though faint, carries hints of color. An edge of pale green from carbon-bearing molecules fluorescing in ultraviolet radiation, mixed with faint traces of blue, where ionized gases are swept into space. To the naked eye it might look only grayish-white, but through filters and instruments, its light reveals a palette that tells a chemical story. The coma gives rise to the feature most associated with comets, the tail. As gases expand, they are driven back by the relentless pressure of the sun, dust, and ions. Caught in that outward flow, stretch away to form long, luminous trails that can extend millions of kilometers. But the tail of a comet does not behave the way many imagine. It does not stream neatly behind like a scarf fluttering in the wind of the comet's own motion. Instead, It always points away from the sun. Even when the comet is departing, racing outward into the cold, its tail is still pushed forward, away from the sun, so that sometimes it seems to precede the traveler rather than follow. This reversal can be startling, as if the comet is being chased by its own light. Atlas displays this subtle defiance. Its tail, though faint compared to the grand banners of some historical comets, drifts outward, not as a sign of speed, but as a compass needle pointing away from the solar furnace. For observers expecting a trailing banner, this detail is a reminder of the forces at play: radiation, magnetism, and solar wind sculpting matter on a colossal scale. The dust tail reflects sunlight in soft, muted brightness, while the ion tail, almost imperceptible without instruments, shimmers faintly in blue as charged particles fluoresce. Together they form a dual plume, fragile yet vast, like brushstrokes of light across the void. The colors are subtle but telling. Green is often the shade of diatomic carbon. See two molecules that glow as sunlight excites them. Blue belongs to carbon monoxide ions, stripped of electrons and driven into fluorescence. These hues, though faint, mark Atlas as an emissary from conditions unlike those in which our own comets formed. Its chemistry is slightly off from the norms we expect, a fingerprint of another planetary nursery. To those who know how to read it, the Coma is not just a glow, it is a signature, an autograph written in the spectrum of alien light. And yet, beyond the science, there is something almost tender in watching a comet's coma bloom. This is matter that has remained unchanged for billions of years, sealed in darkness far from any sun, suddenly let loose by our own. Every puff of vapor is a breath of antiquity, a whisper of conditions that existed long before our Earth formed. For Atlas, this awakening is both revelation and farewell. The coma grows only as long as it is close to the sun. Once it passes beyond, the heat will wane, the gases will refreeze, and the glow will fade. What now appears as a luminous traveler will once again become a silent shard, indistinguishable from the countless stones of interstellar night. For now, though, we are fortunate to witness its brief season of light. Even if the coma is faint, even if the tail is delicate, its presence is a reminder that this visitor is alive in the way only comets can be alive. Responsive, dynamic, shaped by the sun's warmth as it drifts through. It is a halo born of chemistry and light, a veil woven from the memory of another star system. And while it will never return, the image of its glow remains as proof that for a fleeting moment, far from its birthplace, Atlas revealed itself in colors too soft for most to notice, but too wondrous to be forgotten. Deep within the glow of a comet's coma, hidden beneath the spreading dust and gas, lies its heart, the nucleus. For Atlas, that nucleus is small by cosmic standards, no larger than a modest mountain on Earth. Astronomers estimate its diameter at somewhere between 1 and 2 kilometers across, a mere speck compared to a planet, yet vast enough to carry the weight of an alien history. It is from that compact fragment that everything else emerges. The halo, the tail, the faint light we see. Without the nucleus, there is nothing but an invisible rock adrift in space. With it, there is the fleeting spectacle of a comet alive in sunlight. We cannot see Atlas's nucleus directly. Even the most powerful telescopes on Earth and in orbit show only the blurred glow of its coma, the surrounding haze that masks the core within. Cometary nuclei are notoriously difficult to observe. Their small size and dark surfaces make them nearly invisible, except when they awaken near a star. But by the time they awaken, their shrouds conceal them. It is like trying to discern the shape of a candle hidden behind its flame. Instruments must rely on inference, the rate at which gases escape, the brightness of the coma, the angle of sunlight scattering off the dust. From those clues, astronomers piece together a picture of the solid body inside, unseen yet central. Models suggest that Atlas's nucleus is irregular, probably not a neat sphere but a lumpy, elongated fragment. Most cometary nuclei are misshapen, sculpted not by symmetry but by violence. Collisions, fractures, uneven sublimation, as ices vaporize over time. Some spin slowly, others tumble chaotically. Atlas, too, is likely a jagged shard, perhaps with pits and cliffs, ridges and hollows. Its contours are guesses rendered from the behavior of its coma, like reading the silhouette of an object through its shadow. What is certain is that it is not smooth and not uniform. It is the relic of a planetesimal that never became a planet, an unfinished piece of a story from a star system far away. The nucleus is darker than most people imagine. It is tempting to picture it as gleaming ice, white and crystalline, sparkling in sunlight. But cometary surfaces are the opposite. They are darker than asphalt, darker even than coal, absorbing almost all the light that touches them. Dust and complex carbon compounds coat the ice in a crust of blackness, a skin formed by billions of years of exposure to cosmic rays and ultraviolet radiation. The sun's heat burns off the more volatile substances, leaving behind a residue of tar-like organics. Over time, each outburst of sublimation exposes fresh layers, which darken in turn. Atlas, born in another system, has endured its own eons of processing, and its surface now bears the same ink-black finish. When we look at its faint glow, we are not seeing the nucleus shine. We are seeing the gases it releases. The heart itself remains in darkness, yet within that darkness, the interior may preserve something astonishing. Beneath the crust, protected by layers of dust and frozen rock, lie ices that have not melted since the day Atlas was born. Water, carbon dioxide, carbon monoxide, and perhaps more. Exotic volatiles remain locked in its core, preserved like fossils in permafrost. These ices are not from our sun's nebula. They are the products of another star's nursery, the chemical fingerprints of a system we will never visit. In them may linger ratios of isotopes subtly different from our own, balances of carbon and oxygen shaped by alien conditions. To study them, even from afar, is to hold a fragment of another world in our grasp. This is why astronomers are so captivated by interstellar comets. Our local comets are time capsules of our own history, frozen remnants from the solar system's youth. But interstellar comets are time capsules from someone else's history, carrying within them the echoes of distant creation. Atlas is not just an icy rock. It is evidence that planetary systems everywhere shed such fragments, that worlds beyond our sun give birth to their own comets, and that those comets sometimes wander into our skies. The nucleus, silent and unseen, is the vessel of that message. As Atlas approaches the sun, its surface layers will erode, releasing plumes that reveal some of its inner secrets. But the deeper core will remain untouched, sealed away as it has been for billions of years, destined to return to silence once it drifts back into interstellar space. That core, compact and unlit, will continue its journey long after it leaves us, carrying its alien ices through the galaxy, perhaps never to encounter another star again. For now, we can only imagine its shape, its color, its texture. We cannot reach it. But we know it is there, the nucleus within the glow, the hidden heart of the visitor we call Atlas. To think of it is to feel a mix of awe and humility. 1 or 2 kilometers across, no larger than a city, yet carrying within it the story of a world we cannot see. It is a piece of elsewhere, preserved in black ice and stone, passing close enough for us to glimpse, but never close enough to touch. And in that way, it reminds us of the vastness of the universe, and the small but luminous ways in which it occasionally lets us know we are not alone. When sunlight first reached Atlas, the gases it released began to tell a story. Instruments trained on its faint glow caught the unmistakable signature of water vapor, molecules of H2O escaping from the icy body as the heat of our star touched it for the first time in perhaps millions of years. Water is the common denominator of comets, the familiar breath they exhale when they wake. But here, in this interstellar traveler, Water was only part of the tale. The balance of its chemistry was tilted, weighted toward ingredients not usually so dominant in our local comets. Most comets born in the Oort cloud or Kuiper belt are rich in water, yes, but they usually release it in proportions where other gases, carbon dioxide, carbon monoxide, play supporting roles. In Atlas, the chemistry inverted that expectation. The concentration of carbon dioxide was startlingly high, far greater than seen in the comets of our solar system. Observations confirmed that much of the vapor rising from its nucleus was not water at all but CO2, venting into space in plumes that glittered faintly in ultraviolet and infrared. The comet was breathing, but its breath was unfamiliar, carrying the tang of a world colder, harsher, and stranger than our own. Alongside the water and carbon dioxide were traces of carbon monoxide, another volatile that sublimates at extremely low temperatures. Its presence suggested that the nucleus had preserved ices formed in the deepest freeze, where starlight was faint or absent. In comets of our solar system, carbon monoxide appears, but usually in modest amounts, often buried deeper than water or CO2, released later as the comet approaches closer to the Sun. In Atlas, even these faint wisps of CO were detectable early, hinting that the object had spent much of its history in a region so cold that these fragile molecules had never been driven off, locked in place since its birth. To astronomers, this balance of volatiles marks a clear difference. Local comets, especially those studied up close by spacecraft like Rosetta at 67P divided by Churyumov-Gerasimenko, show compositions with water as the primary actor, sometimes joined by smaller percentages of carbon dioxide and carbon monoxide. Atlas reverses that balance, making CO2 not the minor note, but the central chord. The ratios don't align with what we expect from our own solar nursery. That is what makes it so compelling. Its chemistry doesn't just tell us that it is interstellar. It tells us something about the kind of place where it formed. The birthplace of Atlas must have been a region colder than the edges of our Oort cloud, a disk of frozen material circling another star where sunlight was so weak that carbon dioxide could freeze in abundance. Perhaps it formed farther from its parent star than Pluto lies from ours, in the distant outskirts of an alien planetary system. Or perhaps that star itself was smaller, dimmer, radiating so little heat that even close-in regions were icy. Each molecule rising from Atlas's Coma carries a clue, a signature of conditions written into chemistry billions of years ago. We cannot see the star it came from, cannot map its home system, but by analyzing the gases it sheds, we glimpse the fingerprints of that unseen world. The difference matters because it expands our picture of how planetary systems form. If comets in our solar system are mostly water with touches of other volatiles, and Atlas is largely carbon dioxide, then we know that nature produces variety. Not every planetary nursery yields the same recipe. Some bake their comets with water as the dominant ice. Others lay them down in CO2, rich mantles. And all of them, scattered across the galaxy, can release their fragments into interstellar space, where they drift until they happen upon another star to briefly illuminate them. Atlas, in its chemistry, is a message in a bottle. The water vapor connects it to us, a universal solvent that seems to appear wherever conditions allow. The carbon dioxide reminds us that it is foreign, tuned to a colder equilibrium, carrying memories of frostbite environments our own sun could not sustain. And the carbon monoxide, fragile and fleeting, whispers of just how untouched it has remained during its long exile, preserving the delicate ices of its birth cloud through ages of travel in the galactic dark. To gaze at its coma is to watch those molecules escape, transformed into light by the sun, but to understand them is to recognize what they mean, a piece of another system's story breathed into our skies. Each trace of vapor is ancient, each ratio a fossil of alien conditions, dissolving into space before our eyes. And though the comet will leave, its chemistry remains recorded, a permanent note in the expanding symphony of interstellar science. Atlas does not just pass through. It teaches, molecule by molecule, that the galaxy's diversity is greater than we imagined, and that even in faint vapors, there is the unmistakable voice of another world. When we look at Atlas, what we are really seeing is an exile. Its journey through our skies is only a brief interlude in a story that began far away, in a planetary system we will never know. Astronomers believe that long ago, perhaps billions of years ago, it was cast out of its birthplace by the gravity of a giant planet or the crowded dance of young worlds. One violent encounter would have been enough. A close approach that slingshotted the small icy body past escape velocity, unbinding it from its star and throwing it into the void. That moment of ejection was its first farewell, the beginning of a journey that has carried it across the galaxy to us. The age of Atlas is almost unimaginable. Our sun is about 4.6 billion years old, but there is every chance that Atlas is older still. Its chemistry hints at formation. In a cold, ancient environment, one perhaps belonging to a star that lived and died before our solar system even formed. If so, the comet's very atoms predate the Earth, Mars, Jupiter, everything we know as home. When astronomers estimate the timeline, they find no contradiction in placing Atlas at 5, 6, even 7 billion years of age. In other words, when the nebula that would become our sun was still a swirl of gas and dust, Atlas was already adrift, carrying the frozen imprint of another world. It most likely formed in the outer disk of its home system, far from the warmth of its star. In such regions, ices condense, and comets are born out of the leftovers of planet-making. Unlike the inner zones, where rocky planets emerge, the outer edges are littered with icy planetesimals that rarely become worlds in their own right. Atlas would have been one of these. Small, frozen, quietly circling in the dim light, a piece of unfulfilled potential. But then came instability, the shuffle of migrating planets, or a gravitational resonance that nudged it inward. There, an encounter with a massive body sent it hurtling outward at escape speed. It left behind the star that had given it shape, flung into the vast dark between suns. That exile has lasted ever since. Across billions of years, Atlas has traveled interstellar space, crossing gulfs so wide that light takes centuries to span them. In that time, stars have been born, lived, and died. Galaxies have shifted, and entire civilizations have risen and fallen on Earth. Yet Atlas has simply continued on its way, silent and unchanged, a cold ember drifting through the dark ocean of the Milky Way. Its orbit tells us this story, because only such enormous stretches of time can explain how an object could wander for so long before chance placed it near our sun. There is something humbling in knowing that this comet has seen more of the galaxy than we ever will. It has passed through interstellar clouds, past the outskirts of other systems, through the tidal pull of the galactic arms. It has endured cosmic rays, the occasional brush of distant stars' gravity, and still it has survived, intact enough to glow when sunlight finally reached it again. Its interior has remained sealed all this time, preserving the chemistry of its birthplace like an ancient scroll carried across the universe. When its ices sublimate now, they are releasing air older than our world, breath exhaled for the first time since the dawn of its creation. To say Atlas is older than the sun is not just a scientific possibility, but a reminder of how small our timeline is compared to the galaxies. We think of our solar system as ancient, yet it is young in cosmic terms, one generation among many. Atlas carries within it proof that stars before ours had their own comets, their own disks, their own dramas of birth and scattering. It is a survivor from a chapter of galactic history written long before we existed. And it has been moving, unstopped, for longer than we can easily comprehend. Even now, as we catch sight of it for this fleeting passage, it is only pausing in our awareness. Soon it will move on, fading back into the dark, continuing its journey for billions more years perhaps, until it is either eroded to nothing by starlight or captured, at last, by the pull of another star. For us, its story is a brief one, a visitor seen and gone. But for the galaxy, Atlas is an ancient pilgrim, older than our sun, still walking the road that began with its ejection so long ago. When scientists speak of Atlas's birthplace, they speak not in terms of countries or continents, not even in terms of planets, but of regions of the galaxy itself. Its chemistry and its trajectory suggest that it may have originated in what astronomers call the thick disk of the Milky Way. A vast population of older stars and their remnants settled above and below the thin, bright band of stars we see stretched across the night. The thick disk is quieter, less crowded with the blue-white fires of youth, and more suffused with ancient suns that burned billions of years ago. If Atlas was born there, its icy body carries within it the memory of a different era of galactic history, one older and colder than the cradle of our own solar system. The balance of its volatiles, so rich in carbon dioxide, so laced with fragile molecules like carbon monoxide, hints at conditions that were harsher than those of our sun's nursery. Our local comets usually formed under the glow of a relatively young star, enriched with heavy elements produced in more recent generations of supernovae. Atlas, by contrast, seems to bear the fingerprints of an environment shaped by older stars, stars that lived and died long before the sun was born. Those ancient stars left behind different chemical balances, different ratios of carbon to oxygen, different reservoirs of dust and gas. From that material, comets like Atlas were born. Its body is therefore not only a fragment of another system, but an echo of the galaxy's more ancient chemistry, a relic from a time when the Milky Way was still settling into its present shape. The process that set Atlas adrift is one we understand intimately because we see echoes of it in our own backyard. In our solar system, Jupiter is the great ejector, a giant planet whose mass and gravity dominate the orbits of countless small bodies. When comets from the Oort cloud wander inward, a close pass by Jupiter can fling them outward at enormous speeds, sometimes hurling them entirely beyond the pull of the sun. Over billions of years, Jupiter has acted like a slingshot, shaping the orbits of asteroids and comets, and even casting some into interstellar exile. The same story likely unfolded in Atlas's birthplace, a giant planet, massive like Jupiter, or perhaps even larger, swept near the young comet, and with one decisive encounter gave it enough energy to escape. That push sent it on a journey not just across its own system, but across the galaxy. There is a strange symmetry in this parallel. Just as our solar system casts out its fragments, other systems do the same. Atlas is proof of that universality. The same rules of gravity, the same restless exchanges of energy apply everywhere. In a sense, Atlas is a message from another Jupiter, a planetary sibling orbiting a star we cannot see, doing what our Jupiter has done countless times, scattering icy seeds into the galactic dark. For every one that drifts our way, there are untold billions more that go elsewhere, wandering unobserved through the spiral arms. And that is perhaps the most sobering thought. Atlas is not unique in being exiled. It is unique only in that we happen to see it. The galaxy must be full of such fragments, comets, asteroids, icy bodies, ejected in the early violence of star systems and sent drifting forever. For every one we detect, millions pass unseen, faint specks never illuminated by the right angle of sunlight, never falling within the reach of our telescopes. The Milky Way may be as much a sea of these wanderers as it is of stars, a hidden population crossing the void, carrying the chemistry of countless nurseries in their frozen cores. Atlas, then, is not just a single comet. It is a representative. It is a reminder that our galaxy is stitched together not only by stars and planets, but by the debris those worlds shed, fragments that travel endlessly between systems. Its galactic origin story is written in its orbit and its chemistry, a tale of an ancient birth in the thick disk, of violent exile by a giant planet, and a billion-year pilgrimage through the Milky Way. To glimpse it now, for this short passage, is to catch sight of a pattern that spans the galaxy itself, a pattern of scattering and wandering, of exile and encounter, repeated endlessly across the stars. The list of known interstellar visitors is astonishingly short. In all the centuries that human eyes have traced the sky, only 3 objects have ever been confirmed to come from beyond our solar system. The first was Oumuamua in 2017, the second Borisov in 2019, and now Atlas in 2025. To say that they are rare is almost an understatement. Billions of comets and asteroids have been catalogued within our own solar system, yet only 3 have been proven to hail from another star. Each one is like a message in a bottle from the galactic ocean, carried to us against staggering odds. Oumuamua appeared suddenly, detected only after it had already passed closest to the sun. Its shape was inferred to be elongated, perhaps like a shard, and it showed no visible coma or tail. Its strangeness was compounded by its acceleration, behavior that resisted easy explanation. It came and went in weeks, too fast for detailed study, leaving behind only speculation and mystery. Borisov, discovered 2 years later, was far more familiar. It displayed a tail, a glowing coma, behaving much like the comets of our own system, though its chemistry revealed subtle differences. Borisov was the first interstellar comet we could truly watch in action. And then came Atlas, the third, brighter than Oumuamua, more alien in chemistry than Borisov, and detected early enough to observe in unprecedented detail. The rarity of these discoveries is not because such visitors are themselves uncommon. In fact, astronomers are convinced the galaxy is flooded with them. Every planetary system ejects debris, comets, asteroids, fragments, flung out during the restless migrations of giant planets. Over billions of years, the Milky Way has been seeded with countless wandering objects, each carrying the chemistry of its birthplace. They are not rare in number, but in detection. Most are too small, too faint, and too fast to be seen. The probability of one crossing close enough to Earth, at just the right time, within the reach of our surveys, is vanishingly slim. And yet, 3 times now, luck and technology have conspired to let us glimpse them. That luck is changing because our tools are improving. The Atlas survey that found 3I Atlas is one of several modern sky scanning systems designed to look for faint moving points of light. These networks sweep enormous swaths of sky night after night, comparing images, alerting astronomers when something unusual appears. Future facilities, like the Vera C. Rubin Observatory, will expand this effort dramatically, watching the heavens with an intensity and depth never before possible. With such instruments, the probability of detecting interstellar visitors rises, turning what was once a miracle of coincidence into a reasonable expectation. The age of chance encounters is becoming the age of discovery. Even so, most still slip by unseen. For every Oumuamua or Borisov or Atlas, there are likely thousands drifting silently through the solar system each year, their paths never intersecting with our gaze. Some are too small to catch light, others too far from Earth to appear more than faint shadows in the background. They pass by unannounced, carrying their alien signatures with them, lost to us forever. The 3 we have seen are not exceptions. They are representatives of a much larger, hidden population. They are the visible crest of a wave that mostly passes below the surface. This is why Atlas matters so much. It is not just the 3rd interstellar visitor. It is the first found early enough to study extensively, the first to combine detectability with rich chemistry, the first to arrive in a scientific era prepared to record it from every angle. Oumuamua was too fast and too puzzling, Borisov too faint and too fleeting. Atlas is different. It has given us time to prepare, time to point the best instruments humanity has ever built at its glow, time to capture its message before it fades. For scientists, This is a turning point, the moment interstellar visitors shifted from curiosity to science. To call Atlas a turning point is to recognize that it is changing how we see the galaxy. It confirms what theory long suggested, that these wanderers are everywhere, that the gulf between stars is not empty, but alive with fragments of worlds. It shows us that detection is possible, not as a stroke of luck once in a generation, but as a reality of careful watching. It promises that Atlas will not be the last, but one of many we will meet in the years ahead. Its passage is more than an encounter. It is the beginning of a new chapter in our relationship with the stars, a chapter where the galaxy does not remain distant and abstract, but sends emissaries we can measure, study, and understand. The question of how rare interstellar visitors are is no longer answered by the silence of centuries. It is answered by the three names we now carry: Oumuamua, Borisov, Atlas, and by the certainty that others are already on their way. The story of Atlas's arrival on Earth's stage began in silence, in the clicking rhythm of cameras mounted on the Atlas survey telescopes in Hawaii. These wide-field instruments were not built to chase beauty, but to stand guard. Their mandate is vigilance, searching the sky for asteroids that might one day cross Earth's path, scanning each night for faint intruders. It was during such a routine watch that Atlas first appeared, a faint point of light just bright enough to be flagged by the system's algorithms. At first, it looked like any other small discovery, one of hundreds logged by surveys each year. But the motion betrayed something stranger, and almost immediately, the alert spread through the scientific community. Once the candidate was marked, it needed confirmation. That call was answered by larger, sharper eyes. Gemini South, perched in the Chilean Andes, turned its massive 8-meter mirror toward the faint newcomer. Unlike the survey cameras that capture broad swaths of sky, Gemini South peers with precision, resolving details, invisible to smaller lenses. In its images, the faint blur revealed the beginnings of a coma, the swelling haze that confirmed Atlas was indeed a comet. More importantly, the trajectory calculations tightened. With every night of data, the numbers pointed to the same conclusion. Atlas was not bound to the sun. The hyperbolic orbit was undeniable. Another interstellar traveler had come. Hubble, orbiting far above Earth's atmosphere, was soon enlisted to add its gaze. From space, the distortion of air disappears, and the clarity is absolute. Hubble's instruments dissected the light of Atlas, pulling apart its wavelengths to uncover the composition of the gases rising from its nucleus. Water vapor, carbon dioxide, traces of carbon monoxide. These signatures appeared in its spectrum, painting a picture of a chemistry unlike the comets we know best. Even as Atlas drifted faintly in the blackness, the instruments could read its breath, every photon carrying whispers of its alien origin. For scientists, it was like having a library card to a book written in another language, yet still legible with the right tools. But it wasn't only professionals with billion-dollar telescopes who turned to watch Atlas. Word spread quickly through the community of amateur astronomers, the backyard stargazers who carry their own passion for the sky. Across rooftops and fields, in deserts and rural darkness, small telescopes were pointed toward the speck. Some observers captured images with CCD cameras, stacking exposures until the faint glow revealed itself. Others simply lingered at the eyepiece, watching for the smudge that marked a visitor from beyond. For many, the joy lay not in the quality of the view, but in the knowledge of what they were looking at. Not just another comet, but a messenger from another star. To glimpse it, however faintly, was to share in the same wonder carried by the most powerful observatories on Earth. If you wanted to see it yourself, patience and preparation were required. Atlas was never destined to blaze across the sky like a great comet of old. Its brightness hovered near the edge of naked-eye visibility, demanding clear skies and minimal light pollution to stand a chance. Binoculars improved the odds. A small telescope, even more so. Star maps published by observatories guided observers to its coordinates, marking its slow drift across constellations. Those who tried often found the challenge itself rewarding. The reward was a dim glow, a blur of light that would be easy to dismiss as an artifact if not for the knowledge of what it represented. The faintness became part of its power, a reminder of the fragility of its presence and the improbability of seeing it at all. Watching Atlas from Earth was an act of connection, from survey telescopes scanning automatically, to giants like Gemini and Hubble, to small backyard lenses under quiet skies. Each observer contributed a fragment of the story. The comet's light, after traveling for billions of years, entered detectors and eyes alike, recorded in numbers and images and memories. In that shared act, the distance between professional science and private wonder dissolved. Atlas was for everyone, its message universal. For a few short months, it offered humanity a chance to look up, to trace a faint glow, and know it came not from our sun's family, but from another star's long-vanished world, wandering into ours for one brief encounter. The James Webb Space Telescope has always been described as a time machine, capable of looking back billions of years into the first moments of the universe. Yet for Atlas, this telescope is not gazing into the distant past of galaxies, but into the frozen history of a single comet. It is perfect for such a task because it sees in infrared, the very wavelengths where cold ices and dust reveal themselves most clearly. While the human eye can only catch the faint glow of sunlight scattered by Atlas's Coma, Webb can see the heat signature of molecules, the vibrations of bonds in water, carbon dioxide, and carbon monoxide. For an interstellar comet whose story is written in its chemistry, this is the kind of vision that matters most. Infrared light carries the fingerprints of ices. Each molecule absorbs and emits at characteristic wavelengths, producing a pattern that can be read like an elemental signature. When Webb points its mirrors at Atlas, it is not just watching a glow in the dark. It is dissecting that glow, unraveling it into spectra that tell which gases are present and in what abundance. In those faint bands of light are revelations about temperature, volatility, and the balance of elements preserved since Atlas was born. With its unparalleled sensitivity, Webb can detect even trace amounts of compounds that ground-based telescopes cannot reach. Molecules too faint to leave a mark in visible light, but strong enough to echo in the infrared. Early results from Webb's observations have confirmed what ground-based instruments suggested but could not fully prove. Atlas releases water vapor, as all comets do, but its outgassing is dominated by carbon dioxide, far more than is typical for the comets of our solar system. It also carries measurable amounts of carbon monoxide, a volatile that sublimates only in the coldest conditions. The ratios are strikingly different from what we know at home, making Atlas not just another comet but a truly foreign specimen. In its faint breath, Webb has caught the smell of an alien nursery, the chemical memory of a world we will never see. The comparison to local comets is inevitable. Our Oort cloud comets, frozen for billions of years in the outer reaches of the solar system, usually carry water as their dominant ice, with smaller contributions from carbon dioxide and monoxide. Their chemistry reflects the conditions of the sun's protoplanetary disk, where temperatures dropped but not enough to allow CO2 to dominate. Atlas, however, suggests something else. Its high carbon dioxide content implies that it formed in a colder region, perhaps much farther from its star than most of our comets did, or in the shadow of a weaker, dimmer sun. By holding up Atlas against the template of our own comets, astronomers see both similarity and difference. The same broad palette of ices, but painted in a different proportion. This difference may seem subtle, but it carries immense weight for planetary science. If planetary systems across the galaxy can produce comets with such varied chemistries, then the processes of planet formation are more diverse than our single example would suggest. The building blocks of worlds are not uniform. Each star's nursery may freeze its comets to a slightly different recipe, mixing water, carbon dioxide, and carbon monoxide in balances unique to its temperature, metallicity, and history. Atlas is not just an object to be catalogued. It is evidence that the diversity of planets we see in exoplanet surveys extends down to the smallest bodies, that the raw materials themselves vary across the galaxy. For scientists, Webb's data is more than a measurement. It is a reminder that we are not limited to studying alien systems from afar. Sometimes, fragments from those systems come to us, and when they do, we can examine them not just with curiosity, but with the finest instruments humanity has ever built. Every spectrum captured by Webb is a page of a story that stretches beyond our solar system, showing that the chemistry of comets is not bound to one star, but shaped by the galaxy itself. Atlas is only one comet, and yet, in its light, planetary science expands. It is no longer only the story of how our sun made its worlds, but how stars everywhere scatter their icy seeds, and how sometimes those seeds drift far enough to cross another star's sky. In that sense, the James Webb's gaze is not only perfect for interstellar comets, it is perfect for the kind of science that recognizes the extraordinary in the faintest of signals, the universal truths hidden in the breath of a comet from another sun. What Webb reveals in Atlas may reshape not just how we classify comets, but how we understand the galaxy itself. A place where every star writes its own recipe for life's ingredients, and sometimes shares them with others across the long, dark corridors of space. The chemistry of Atlas is more than a curiosity. It is a set of clues, preserved in frozen molecules, pointing backward to the conditions of its birth. When astronomers studied the gases streaming from its coma, they found not only the expected water vapor, but something unusual in its balance. The comet's breath was dominated by carbon dioxide, far more than we see in comets from our own solar system. Water was present, yes, but not in its usual place as the leading voice of the chorus. Here, CO2 carried the melody, hinting at an origin colder, darker, and more remote than the nurseries that shaped our Oort cloud. The dominance of carbon dioxide suggests that Atlas formed at temperatures where water could still remain locked as ice, but where CO2 condensed in abundance as well. In our own system, such conditions exist only in the outermost fringes, far beyond Neptune, in the deep freeze of the protoplanetary disk. But even there, comets usually contain more water than CO2. Atlas's reversed proportions may mean its home star was smaller and dimmer, radiating less heat, or that it formed in a region far beyond what our sun's disk could sustain. Its chemistry tells of a birthplace where sunlight was too weak to favor water, where carbon dioxide instead became the scaffolding of frozen bodies. Equally important is what Atlas lacks. Compared to many comets we know, its spectrum shows fewer heavy elements, fewer complex compounds, enriched by generations of stellar recycling. That absence hints at a star system older than ours, born before the galaxy's furnaces had fully seeded the interstellar medium with metals and silicates. If so, Atlas is not just foreign, but ancient, carrying within it the simplicity of an earlier cosmic era. It may predate Earth not only in age, but in the very maturity of the matter from which it was made. To sample its vapors is to breathe in the chemistry of an earlier galaxy. The heavy presence of carbon dioxide has another meaning too. CO2 is a greenhouse gas, central to the atmospheres of planets, shaping climates, warming surfaces, and influencing the potential for life. On Earth, it is tied to cycles of geology and biology. On Mars and Venus, it dominates the air. To see it as the most abundant, volatile in Atlas suggests that the building blocks of planetary atmospheres vary across the galaxy. If its home system seeded worlds with CO2-rich comets, their planets may have worn very different skies than ours, perhaps wrapped in thick, cold blankets of carbon dioxide, or bearing thin traces of water compared to what we know here. The chemistry of one comet becomes, in this sense, a clue to the climates of exoplanets we cannot see. In this way, Atlas is not only a comet, but a probe of alien chemistry. It drifts through our solar system, carrying evidence of conditions far beyond our reach. It shows us that comets elsewhere conform to different recipes, that our own icy bodies are only one version of what nature allows. Its frozen gases are like samples hand-delivered from a star system we will never visit, molecules preserved through billions of years and released now in sunlight for our instruments to catch. Every spectral line recorded from its coma is a window into an environment once too distant to imagine, now briefly revealed. And in the grander view, it reminds us of how interconnected the galaxy is. Atlas's ices are not locked away forever in their place of birth. They have traveled, carried across the void, to be released in our skies. For a short time, we get to see them, study them, and understand what they mean. They are not just ices, not just gases. They are fragments of another story, one that tells of colder regions, older stars, alien atmospheres, and the boundless creativity of a universe that builds worlds in many ways, not just the way it built ours. Atlas is not drifting leisurely through the solar system. It is racing, carrying with it the unmistakable signature of hypervelocity, a speed so great that nothing within the sun's gravity can ever claim it. Calculations show it is moving faster than any comet native to our system, a motion written in its hyperbolic path. This is the defining quality of an interstellar visitor. It comes in fast, it leaves just as fast, and nothing can slow it enough to bind it. Its speed is both the reason it can reach us and the reason it will never return. When it departs, it will not pause at the edge of the solar system or linger in the Oort cloud. It will continue outward, slipping past Neptune, past Pluto's orbit, and out into the deep black of interstellar space. In a few decades, it will be lost to any telescope we have, shrinking into invisibility. But invisibility does not mean stillness. For millions, perhaps billions of years, Atlas will continue its journey, coasting along a trajectory that will carry it across the galaxy. It will pass within light years of other stars, through regions where alien planets orbit, through clouds of gas and dust, perhaps even through the outskirts of other planetary systems. It is a traveler with no destination, a thread in the galaxy's endless weaving. Astronomers sometimes describe objects like this as galactic dust, not dust in the sense of tiny particles, but in the sense of endless fragments, countless small bodies, expelled from the systems that birthed them. Just as dust drifts in a beam of light, these comets and asteroids drift in the galactic disk, each a tiny shard of a world, scattered and set loose. Atlas is one mote among trillions, one grain suspended in a beam of starlight that spans 100,000 light years. When we see it, we are reminded that the galaxy is not only stars and gas, but also these invisible drifters, silent and innumerable. Its speed guarantees encounters. In the course of its long voyage, Atlas will cross the neighborhoods of stars, each encounter tugging its path ever so slightly. It may pass within a few light years of dozens, perhaps hundreds of stars, before the galaxy's rotation carries it onward. Each close passage is a meeting without awareness. The comet passes, the stars shine on, and the drift continues. And yet these meetings are not meaningless. They are the slow mixing of the galaxy, the way matter from one system ends up elsewhere, stirred by gravity and chance. Every comet ejected becomes a wanderer, and every wanderer becomes a potential messenger, carrying the story of one system into the skies of another. What Atlas tells us, then, is that the galaxy is not made of separate, sealed worlds. It is porous, connected, alive with exchange. The comets of one star can become the visitors of another. The dust of distant nurseries can one day pass before our eyes. Galactic mixing is not abstract theory, but a visible truth embodied in this comet's glow. Atlas may be only one object, but it stands for countless others, and together they reveal a Milky Way where systems share their debris as naturally as tides share water. In that light, Atlas is more than just a fleeting point in the sky. It is proof that nothing in the galaxy is isolated forever. It moves with speed. It moves with purpose, written not in intention but in the laws of physics, and in its motion, it reminds us that we are part of something vast and interconnected. The same gravity that will one day send fragments of our own system drifting outward has already delivered Atlas to us. And now, as it speeds away, we witness in real time the exchange of matter between stars, the circulation of a galaxy, alive with motion. When Atlas was first spotted, a familiar frustration settled over the scientific community, the realization that we were not ready to go to it. Objects like this move too fast, arrive without warning, and depart on timescales too short for us to respond with spacecraft already sitting on launch pads. By the time a mission could be designed, built, and launched, the comet would already be gone, receding into darkness at tens of kilometers per second. For all the sophistication of our telescopes, we remain observers, not participants, unable to meet these visitors face to face. This is not a new lament. When Oumuamua flashed through in 2017, there was a flurry of proposals to chase it. Some imagined repurposing existing spacecraft, others dreamed up rapid launches with high-energy rockets. A few even drafted theoretical blueprints for laser-boosted sails that might just catch up. But reality was cruel. Oumuamua was discovered too late, already outbound, and the distances grew too quickly for any practical pursuit. The moment of discovery arrived months after the only window to intercept had already closed. It was like noticing a car racing down the highway, only once its taillights had vanished. Still, those missed chances were not wasted. They planted the seeds of future missions. Concepts like the Interstellar probe began circulating. Spacecraft designed not for a specific target, but as permanent sentinels, launched on high-energy trajectories to lurk in the outer solar system, waiting for the day another object appeared. The European Space Agency's Comet Interceptor is one such effort. Instead of building a craft after discovery, the idea is to launch it in advance, park it in space, and then send it racing to meet whatever interstellar visitor next crosses our skies. It is a bold inversion of the usual model, planning not for a known destination, but for a mystery still to come. Atlas makes these ideas feel urgent. Unlike Oumuamua, it was caught earlier, bright enough and predictable enough to study in detail. But still, we cannot send a spacecraft. We can only watch from afar, record spectra, capture images, and simulate what might have been. For planetary scientists, this is both exhilarating and exasperating. The opportunity is immense, but we lack the tools to seize it fully. Each passing interstellar comet is a reminder of the need to prepare in advance, to have spacecraft capable of rapid response, to design engines and trajectories that can match these fleeting speeds. The truth is that interstellar visitors are now part of our scientific landscape. Oumuamua proved they exist. Borisov showed they can resemble comets we know. Atlas has revealed chemistry more alien than either. Together, they paint a picture of a galaxy filled with such wanderers and of a future in which more will come. To truly learn from them, we will need to move beyond observation and into encounter. We will need ships waiting in the dark, ready to ignite when the next alert comes. That is why Atlas is more than a comet. It is a challenge. Its fleeting passage is a reminder that the galaxy is generous with gifts, but only to those who are prepared to receive them. To watch Atlas fade into the black is to feel the weight of what could have been. A close-up look at alien ices, a direct sample of chemistry from another star. Missions we wish we had remain only dreams for now. But each visitor makes the dreams sharper, the urgency clearer, and the determination stronger. Atlas leaves us not only with data, but with resolve. That next time, we will be ready. The dust of Atlas is more than haze trailing behind a comet. It is the disintegration of another world, tiny fragments of rock and ice set free after an exile of unimaginable length. Each grain that escapes into its glowing coma once lay buried in the body of the comet, locked away for billions of years. They are shards of alien geology, the mineral fingerprints of a planetary system no longer present to us. Seen through our telescopes, the dust appears only as faint light, a glow smeared across the sky. But in reality, it is matter from another star's nursery, sifted into our skies for the briefest of instants. In that dust may lie complex molecules, the kinds we call prebiotic. We know from studying our own comets that carbon chains, organic compounds, and amino acid precursors can form in the icy shells of such bodies. They emerge when radiation interacts with frozen ices, weaving chemistry that leans toward the building blocks of life. If our comets can harbor such beginnings, why not those of another system? To imagine Atlas's dust is to imagine the possibility that molecules crafted under a distant sun in conditions we will never see are now drifting through our solar system. Even if we cannot catch them, even if they disperse into invisibility, the thought itself expands the horizon of what life's precursors might be and where they might originate. The chemistry of Atlas preserves the memory of another star. Locked in its nucleus are the temperatures and compositions of its birthplace. Every release of carbon dioxide, every faint emission of carbon monoxide, every trace of water vapor carries a chemical accent, a dialect of a star system far from our own. It is as if Atlas is whispering across the void. This is what my home was like. This is the air of my childhood sun. We cannot know the planets it orbited with, the giant that flung it away, the history of its star. But through chemistry, we can know the conditions, the flavor of that forgotten sky. The molecules are messages, etched billions of years ago, now delivered by chance into our telescopes. To call Atlas a time capsule is not metaphor alone. It is literal. Its ices have been sealed since its ejection, untouched by the warmth of any star, preserved in the cold vacuum of interstellar space. They have not been recycled through planets or stars, not melted or reformed. They are as ancient as the day they froze. When the sun's heat teases them into vapor, we are watching a capsule unseal, the past escaping into the present. It is a history older than Earth, revealed molecule by molecule. In its trail of gas and dust is a record that survived a journey longer than any human story, intact enough for us to read. And there is poetry in this migration. A comet is small, fragile compared to the stars, yet it carries across the galaxy. Atlas is one of countless wanderers, exiled from its home but still holding within it the essence of that home. Its path through the Milky Way is not aimless but inevitable. The trajectory written by gravity, the story carried by momentum. It will never return, but it will always be a messenger, moving silently from one corner of the galaxy to another, dusting each system it passes with fragments of alien memory. When we watch Atlas, we are not only observing a comet, we are watching the galaxy share itself. We are witnessing the exchange of matter across light years, the circulation of building blocks from one star's nursery to another's night sky. Each grain of dust, each molecule of vapor is an echo of other worlds, their stories carried here in fragile, fleeting form. And for a moment, as Atlas drifts through the field of our vision, we are part of that story too, standing beneath the sky, holding in our awareness a time capsule of alien chemistry and recognizing in its trail the quiet poetry of cosmic migration. Oumuamua was the first, and because it was the first, it arrived cloaked in confusion. When it was detected in 2017, the object was already on its way out of the solar system, moving too fast for us to linger on it with careful eyes. Its light curve betrayed something elongated, perhaps shaped like a cigar, perhaps flattened like a disc, but impossible to pin down with certainty. What struck most was its silence. No coma, no tail, no visible signs of activity. And yet its trajectory shifted ever so slightly, as if some faint outgassing were nudging it. That contradiction, the motion of a comet without the look of one, turned Oumuamua into a puzzle, a riddle still unsolved. It was our first taste of interstellar debris, and it left us with more questions than answers. 2 years later, Borisov entered, and with it came something more familiar. From the moment it was seen, it bore a coma and a tail, the classic appearance of a comet. Unlike Oumuamua, Borisov looked the part, shedding gas and dust as it passed near the sun. But its chemistry was subtly different. Its carbon monoxide levels higher than those found in most local comets. Observers noted its spectrum with excitement, for here at last was confirmation. Interstellar comets exist, and they can be studied as comets, not only as enigmas. Borisov reassured us. It looked alien, but it behaved in ways we understood, offering a bridge between the mysteries of Oumuamua and the expectations of cometary science. And then came Atlas, the third, arriving not with confusion or reassurance, but with revelation. Like Borisov, it displayed a coma and tail, but unlike either of its predecessors, its chemistry has spoken loudly. The dominance of carbon dioxide in its outgassing, the preservation of delicate ices, the faint hints of color in its tail, all of these are more extreme than we have seen before. Atlas is the first interstellar visitor caught early enough to dissect thoroughly, with the James Webb Space Telescope and Earth's most powerful observatories trained on it. In its vapor, we can read the conditions of its birth. In its activity, the behavior of a comet forged in a different stellar nursery. It is not an enigma like Oumuamua, nor simply familiar like Borisov. It is both understandable and alien at once, the clearest messenger yet from beyond our sun. Across the three, the lessons begin to emerge. Oumuamua taught us to expect the unexpected, to recognize that interstellar fragments will not always follow the rules we know. Borisov proved that comets can survive the journey intact, bearing their ices into our skies. Atlas has shown us that chemistry can vary profoundly from system to system, that even when the form is familiar, the substance can surprise us. Together they sketch the beginnings of a pattern, one where interstellar objects are not rare miracles but inevitable visitors, each carrying a different piece of the galaxy's story. Of the three, Atlas may be the most important, not because it is the brightest or the closest, but because it is the one we have truly met on its own terms. It has lingered long enough, shone bright enough, and spoken clearly enough for us to gather its message. It is a comet we can place in context, a bridge between the puzzling silence of Oumuamua and the cometary comfort of Borisov. It tells us that the galaxy's debris is not homogeneous, that the building blocks of worlds differ from star to star. And in that difference lies the proof that our solar system is only one of many recipes, one of countless variations on the theme of planetary birth. Atlas is not the first interstellar guest, nor will it be the last. But it is, so far, the one that has allowed us to listen most carefully and to begin hearing the chorus of other worlds echoing through the dark. In 10,000 years, Atlas will be far beyond the solar system, farther even than the most distant remnants of the Oort cloud. Its trajectory is carrying it outward at tens of kilometers per second, and while those numbers may seem small against the immensity of space, they accumulate relentlessly. Year by year, century by century, the comet pushes farther into the void, leaving the sun as just one faint star behind it. By then, Earth's continents will have shifted, our languages may be unrecognizable, and yet Atlas will still be in motion, silent and unchanged, continuing the journey begun. When it was ejected from its home system billions of years ago, the afterlife of an interstellar comet is not a fiery end, but a slow fading. Unlike comets bound to the sun, it will never return for another bright display. Its activity is temporary, triggered only by this brief encounter with starlight. Once it leaves, the ices that flared into vapor will freeze again, and no star will be close enough to stir them. The coma will dissipate, the tail will vanish, and Atlas will slip back into invisibility. To our eyes, it will become just another rock adrift, indistinguishable from the blackness surrounding it. Only the memory of its visit, preserved in data and stories, will remain visible to us. For most interstellar comets, this is the fate: endless wandering, their brightness spent in a single passage by a single star. They are not destroyed, but neither are they illuminated again. They travel the galactic disk like unlit lanterns, each carrying frozen chemistry from a system long ago. They may drift past hundreds of stars over billions of years, but the chance of another close pass, another moment of light, is slim. The galaxy is vast, its distance is immense. For nearly all of them, wandering is forever. When we think of Atlas in this way, it becomes less an individual and more a representative of a population almost beyond counting. For every one that we have detected, there are billions more moving invisibly. Some may have passed through our solar system unnoticed, too small or faint to catch. Others may be out there now, crossing between the stars, exiled fragments of alien nurseries. Atlas is not singular. It is one among a sea of wanderers, each carrying the story of its origin, each destined to fade into the anonymity of the galactic dark. And yet, for us, Atlas is singular. We met it here, in this moment of history, under the light of our sun. We studied its chemistry, watched its coma, traced its hyperbolic path. For us, it is not just one of billions, but a comet with a name, a story, a place in our understanding of the universe. The galaxy may see it as dust, but for humanity it is a turning point, a messenger, a spark of recognition that our skies are open to visitors from other worlds. The view from the future is sobering but also beautiful. Atlas will go on, unseen, but its passage has already reshaped the way we think of the cosmos. It has reminded us that stars are not isolated, that fragments travel between them, that chemistry and memory migrate across light years. 10,000 years from now, Atlas will still be traveling, but its story will already be part of ours, woven into the long tapestry of how we came to understand the galaxy, not as a distant abstraction, but as a place where other worlds occasionally reach out and touch our own. Life, as far as we know it, begins with chemistry. The simplest molecules link into chains, chains fold into complexity, and complexity opens the possibility of biology. For decades, scientists have suspected that comets might carry these beginnings. In our own solar system, missions like Rosetta revealed that comets hold organic compounds, carbon-rich molecules that resemble some of the precursors to life. Amino acids, sugars, and other building blocks have all been detected in the icy grains released by native comets. They are not alive, but they are ingredients, waiting for the right environment to assemble into something greater. Atlas, by virtue of its alien chemistry, stretches this conversation across the galaxy. If comets in our solar system can carry organics, then comets from other stars might carry their own versions, synthesized under different conditions, sculpted by different stellar histories. Its dust and gases may contain molecules unknown to us, or familiar ones formed in slightly different ratios. Even the faint possibility is profound, because it suggests that the ingredients for life are not bound to a single star or system. They may travel, drifting, across interstellar space, delivered like seeds cast into the wind. This idea has a name: panspermia. It is the hypothesis that life, or at least its precursors, can be distributed across the cosmos by comets, asteroids, or even grains of dust. Most scientists approach it cautiously, not because the chemistry is implausible, but because the leap from molecules to organisms is vast. Still, comets like Atlas add weight to the speculation. If molecules can form on icy bodies, survive interstellar exile, and be delivered to other systems, then the galaxy itself may act as a gardener, scattering possibilities of life across its stars. In Atlas, we glimpse not only chemistry but history. Its high carbon dioxide content and preserved volatiles suggest that it has carried its molecules untouched for billions of years, preserved like artifacts in a vault. If prebiotic molecules formed in its ices back in its home system, then they are still there, crossing the gulf of space to be released now, however faintly, under our sun. For scientists, even detecting simple organics in such an interstellar comet would be a revelation, proof that biology's seeds can be sown in many places, not just here. Comparing Atlas to our own comets sharpens the point. The Rosetta mission found glycine, a simple amino acid, in the vapor of Comet 67P. Other studies revealed sugars and alcohols, the building blocks of biochemistry scattered through the solar system. If local comets hold these treasures, then an interstellar comet like Atlas may carry versions shaped by a different star's nursery under conditions we have never seen. To study them is to compare recipes. Ours, familiar and close to home. Atlas's, foreign and perhaps older. Together they suggest that the galaxy is not stingy with the ingredients of life, but prolific. The presence of such molecules does not mean that Atlas carries life itself, but it does remind us that the galaxy is capable of storing and transporting the raw ingredients over astonishing distances. Atlas becomes not only a comet, but a participant in a cycle larger than any one system. Born in the disk of a distant star, exiled by the gravity of a giant planet, wandering for billions of years, and finally releasing its ices under the warmth of the sun. It is part of the circulation of chemistry, the galaxy's own bloodstream, moving nutrients from one corner to another. There is poetry in that cycle. The dust that now trails behind Atlas is not simply debris. It is matter once part of another world, carried to us in silence, dissolving into our skies. In it could be molecules that once drifted around an alien star, molecules that never knew our sun until now. Atlas, in this sense, is part of the cosmic life cycle, a traveler delivering a message not of certainty, but of possibility. It tells us that life's beginnings are not confined, that chemistry can cross between stars, that the potential for biology is written into the very fabric of the galaxy. We do not yet know whether life exists elsewhere, but when we watch Atlas, we see proof that the ingredients can travel, that the seeds can scatter, that the galaxy is restless with exchange. And if the universe can move molecules this way, then perhaps it can move the story of life itself, passing it from one system to another, until one day, under the right conditions, those seeds awaken. In Atlas, we see not only a comet, but a reminder that life may be less a miracle of one world than a possibility of many. For most of human history, comets carried a burden of dread. Their sudden appearance in the night sky, bright and ghostly with tails unfurling, seemed like ruptures in the order of the heavens. Ancient chroniclers linked them to war, famine, and the deaths of kings. They were seen as omens, streaks of divine displeasure cutting across the stars. Without knowledge of their orbits or their chemistry, people could only interpret them through fear. A comet was a disruption, a warning, something that did not belong. Today, we meet comets with awe instead of terror. Science has unmasked their nature as icy fragments, predictable in their orbits, explicable in their light. Rather than portents of disaster, they are archives of creation, carrying the oldest material of planetary systems. Their sudden brightness does not foretell death but reveals history, the chemistry of birth preserved in frozen vaults. Atlas, in particular, strips away the fear entirely. Knowing that it comes not from our system but from another star, we do not recoil, we marvel. The awe lies in its distance, in its endurance, in the improbable chance that it wandered into our sight. Atlas has become a symbol of interconnection. It reminds us that the galaxy is not a collection of isolated systems sealed off from one another, but a web where matter flows across unimaginable distances. A fragment of one star's nursery can end up glowing in the sky of another, linking distant worlds in the most tangible way. When we look at Atlas, we are looking at the chemistry of a system we will never see directly, carried here by the randomness of gravitational scattering. It shows us that we live in a universe not of boundaries but of exchanges, where even the smallest body is part of a larger circulation, and it teaches us impermanence. The glow we see now is fleeting, a brief illumination before the comet returns to darkness. For billions of years, Atlas was invisible, and for billions more, it will vanish again, a frozen ember wandering the galaxy unseen. Our encounter with it is temporary, a reminder that all moments of wonder are passing. The comet itself embodies impermanence, losing dust and gas with each day, its brightness both a revelation and a diminishment. To admire it is to accept that beauty often arrives hand in hand with transience. Yet impermanence does not diminish meaning, it sharpens it. Atlas inspires because it is fleeting, because it underscores how precious it is to witness a messenger from another world. For scientists, it fuels the drive to prepare missions, to be ready next time, to capture what slips away too quickly now. For dreamers, it opens the imagination to a galaxy alive with motion, to the idea that we are part of a cosmic conversation spoken across light years. Atlas is not just a comet, it is a reminder that we, too, are travelers, that exploration is our nature, and that the next great discoveries may already be on their way to us. In this sense, Atlas joins the long tradition of comets, inspiring human imagination. Where once they conjured fear, now they ignite curiosity. They move us to ask larger questions about where we come from and where we are going. Atlas, with its alien chemistry and interstellar path, deepens that tradition. It shows us a universe where the past and the future are not confined to one star, but shared across many. And in doing so, it leaves us with a simple, enduring truth, that to watch a comet is to glimpse not only ice and dust, but our place in a universe forever in motion. In the weeks after perihelion, Atlas began to dim. Its brightest moment had passed, the rush of vapor and dust driven off by the sun's heat starting to ebb as distance grew. What was once a faint but noticeable smear of light in telescopes became fainter still, shrinking against the backdrop of stars. The coma that had once been a halo around the nucleus dissipated, the tail thinned, and the glow that had captured so much attention slipped back toward invisibility. Its farewell was not sudden, but gradual, a fading note at the end of a song. From there, its exit trajectory carried it outward, accelerating beyond the reach of the sun's gravity. Its path stretched hyperbolic, a one-way escape written in geometry. Every calculation confirmed the same truth. Atlas would never circle back, never return. It would cross Neptune's orbit, leave behind the Kuiper belt, and eventually pass even the tenuous frontier of the Oort cloud. Past that, it would belong again to the galaxy, not to us. Its speed guaranteed that no star could hold it unless by extraordinary chance. The sun's brief grasp was over, and Atlas was free once more. We know, with certainty, that we will never see it again. Not in 10 years, not in 10,000. Its glow will vanish from the sensitivity of our instruments, its coordinates drifting into the black, unreachable by any eye. Future astronomers will not point to its path because it will be gone, too small and faint to matter except in our records. Its single performance is finished. For humanity, the chapter of Atlas closes as quietly as it began, with a speck of light against the Milky Way, now receding forever. And yet what it leaves behind is not nothing. It leaves us knowledge, data gathered in spectra and images, measurements of its orbit and chemistry. It leaves us context, a comparison to the interstellar visitors that came before and those that will surely come after. It leaves us inspiration, the drive to be ready next time, to send missions that can intercept instead of only observe. Perhaps most of all, it leaves us perspective, the realization that the galaxy is not distant but present, flowing through us in the form of wandering debris. There is a legacy in that perspective. For centuries, humanity wondered whether the stars were truly separate, whether what happened around one had any bearing on another. Atlas and its kin have given us the answer. Stars share their fragments. Systems are not isolated. The galaxy mixes itself through these wanderers, spreading its chemistry across light years. Atlas is part of that grand migration, and in witnessing it, we are reminded that our own solar system will someday contribute its own travelers, fragments of us drifting into alien skies. So Atlas departs. It fades into the night, into the catalogs, into the silence of interstellar space. We will not follow it. We will not hold it. We will not see it again. But for the brief span it was here, it showed us what it meant to meet another world, not in person, but in presence, carried across eternity to cross our sky once. One comet, one visitor, one brief encounter in the long story of the galaxy. And though it is gone, we are changed, because for a moment, across the vastness of time and distance, another star reached us, and we noticed.